In the following example, we are asked to calculate the arc length intercepted by a central angle theta in a circle with radius r. So let's first look at what arc length is. If you have a circle with some radius r, the arc length in this case is this blue region here that I've shaded. So if we think about it, say that we wanted to cover this circle with yarn, and I actually only want to cover this part. Well, how would I measure it? Okay, you can't easily go up with a ruler to measure it. So what you're going to do is you could find the radius, and if you knew the angle that was formed here, then using the formula S equals R theta, you could calculate how much yarn you needed to cover this edge right here. Okay, so S equals R theta. R is the radius, and theta is the measure of the angle in radians. So that's very important. So if you did not convert the angle, in this case we're given, in this example, radians, but if it was in degrees, you would have to convert it to radians using the conversion factor that pi radians is 180 degrees. So this example is quite easy. S equals, in this case, R, which is 28.64 feet. Okay. And pi over 16 radians is the measure of our angle. This is R, this is theta. So you can go ahead and do that, perform that operation on your calculator. And rounding to one decimal place, let's suppose, we end up with about 5.6 feet. So if we had this circle with a radius of 28.64 feet, I need about 5.6 feet to cover this opening right here. Okay, so this is how we would calculate arc length, and it's really nice, especially when you can take a look at some applications. And in one of the next videos, we'll take a look at applications of arc length.